completing the square. There's some good detailed notes already written out for you about what completing the square is, so I'm not going to go over all of them. This slide is just kind of a prelude into completing the square. It's talking about what do we do when we have the square root of something we're trying to solve. We've already done this. I've already made you guys do this in the last one. So you're actually pretty good at this. If you look down here at this question, you have x squared minus 4 equals 0. You need to isolate for x. So you move the 4 over. You get square root both sides. And you have x equals positive or negative 2. Is that ringing a bell for everybody? Okay, beautiful. All we did was isolate for x. Moved everything away from x. To get rid of the square right here, we had to square root it. Right here. Those are nice, easy questions. That's your answer. That's easy. Calvin. Calvin. Stop. Hi. That's a good question, because that's something that's new to a lot of people. When you square root something, you get a positive and a negative answer. Because if you took negative 2 and you squared it, the negative cancels itself out. So it equals 4. Which means when you square root something, it actually could have been a negative or a positive. We don't know what this x was. It could have been negative or positive 2. We don't know. Maybe the square changed the negative to a positive. Maybe it didn't. So when you square root things, some of you have already been doing this. Some of you, we talked about this last year. You want a positive and a negative answer. If you cube root something, it doesn't matter as much. We only deal with square roots. Yes. So start answering things positive or negative when you square root things. We'll get more into that, kind of like how that works even more Friday. So if we're doing these examples, how do I get x by itself? Square root both sides. So x is equal to positive or negative 4. That would be my answer. For number 2, minus 5 from both sides. Minus 5, minus 5. I have x squared is equal to 9. Square root both sides. X is equal to positive or negative 3. Number 3, we're going to add 8 to both sides. So now we have 2x squared is equal to 24. We're going to divide by 2. And x squared is equal to 12. You get a square root both sides. You get x is equal to the square root of 12. You could simplify that. But before we simplify that, when you square root something like this, positive, negative, square root 12. So still write that. Let's simplify that 12 just for fun. 4 and 3 multiplied to be 12. So the square root of 4 is 2. So it's equal to plus or minus 2 square root 3. Just one, right?
Why do you have to put the positive negative?
Good question. So in all of our previous questions, the square root worked out to be a nice whole number. And we put positive or negative because it could have been positive or negative that was squared to get that number. So for instance, if we took negative 3 and put it back to the original equation, it would still work. Because negative 3 squared is a positive number. The negatives would cancel themselves out. So we need to put both answers because they're both possible. This one, we put plus or minus for the same reason. We didn't do the square root of 3 because that's. Ty, you have a question?
Is the answer wrong if you have both sides?
You need the plus or the minus. Those are both correct answers, which means that's the entire answer. Otherwise, you've just answered half. Yeah. If you look down at the next two, move the 7 over. So you have 3x squared equals 9.
15.
Divide by, 15. Sorry, I just know where we're headed. Divide by 3. You have x squared equals 5. Ooh, that's going to be 5. Square root both sides, and you get x equals positive or negative square root 5. That's your final answer. Right.
Does it matter if you put the positive and negative upside down? Like if it's bigger on top?
No, it wouldn't matter. In all honesty, you'll see it as positive, negative, like that's the proper way to do it, but it doesn't matter. B. You're gonna have to square it, root it right now, right, to get rid of that square sign. So you square root it right off the bat. Square root, and you're gonna get a really weird answer for this one. You're gonna get x plus 3 is equal to the positive or negative square root 20. Nope, you got to move the 3 over. So subtract 3 from both sides. Put the answer up here so you guys can actually see it back there.
If there's square roots that can leave the
Wait, so
Just wait, Nadia has a question. What is it?
if the square roots that leave the x plus 3 because of this.
Yeah, cancel. Yeah. So we have x equals negative 3 plus or minus the square root of 20. You could go equals plus or minus square root 20 minus 3.
yeah, but let's do
That won't change it. That won't change it. You're good. It looks way different, but it's the same thing. The way on the top, that's the proper way to write it. That's the way you're going to see it. That's probably how you should be used to seeing it. Pardon? Yes. How do we simplify the square root of 20?
Like, when on test, do you actually just simplify it?
Yeah, it'll be simplified. Yeah. You'd have 2 root 5 instead of root 20. And you will need to do that on a test. It's going to be expected that you're just doing that. So that equals negative 30 plus or minus 2 root 5. That is just going to be a skill that's expected to move on. Same with rationalizing denominators. That's going to be just expected to be known. Josh? That's a good question. So we're going to look at what this answer actually means. So right now, you actually have 2 answers. Answer 1 answer number 1 is negative 3 plus 2 root 5. Answer 2 is negative 3 minus 2 root 5. Stop talking. You 4. Stop talking. You have 2 different answers. You have answer 1 where you chose positive, and then you have answer 2 where you chose if it was negative. So that's 2 different things, and you can't combine them because they're not both root 5s. So it would have to be a 3 root 5 and a 2 root 5 to be able to combine them. But right now they're separate things, they're not like terms. But still no. It has to be like terms. So the thing that's screwing them up is this, the root 5. Root 5 is like x. It makes its own term. So root 5 will be its own little term. And then negative 3 is its own little term. Now, they're both correct.
Yeah.
So if this was a, if you plug them both back in, they both get you the right answer. Yeah. And the reason this occurs is if you think about a graph, that's going to be 2 points that would be on a horizontal line. So if you had a graph like this, it might be right here, and it might be right here. But they're both equal to the same y. It's just 2 very different x's. Okay. We've been doing these and just assuming we're getting answers that make sense. Because they have, up to this point. But now they're going to start to not make sense. So for instance, if you look at this question right here, you have 3x squared equals negative 12. Divide both sides by 3. You have x squared is equal to negative 4. Square root both sides. You have x is equal to root negative 4. Plus or minus technically. Can you do a root of a negative 4? No. So if you get a question like that, much like you had on the test, you would have no solution or no real roots, depending on what the question's asking you. This one asks you what are the roots, so you would say, restate the equation has no real roots. That would be your answer. Don't fall for the answer of plus or minus root negative 4, because that's not actually doable. Possible. Cube root would be possible, yes, because you can cube root negatives, and you can fifth root negatives, and you can seventh root negatives. You can do any odd root. Okay.
Would it be possible to do it having a negative 1 for the plus or minus of like 4%?
Negative 1 root 4?
Yeah, like,
So if you look back, and you look at these answers, like this one, that's like there's a negative 1 in front of it. That's what that bottom thing is. That's a negative 1.
okay.
So it would, plus or minus, having a negative 1, it wouldn't make a difference. Is everybody good with that? This is all still kind of review. Kind of new, kind of review. We've been slowly kind of pushing it in there in that last unit, so you saw where we were headed. Okay. Completing the square. We're going to start getting quadratics that we can't solve. So you guys have experienced this before, where you try to factor a quadratic and you can't. And then you try to isolate for x and you can't. And up until this point, we've just been saying it's not factorable, and then move on. Now we're going to say things are factorable, and we're going to show you how they're factorable. So, if you do not have a perfect square quadratic, that means something we can actually factor. You make one, you make it a perfect square factor by completing the square. That's what that blanks are. Completing the square. Right now, that means a whole lot of nothing. But what you need to understand is we're going to take quadratics that can't be factored. We're going to do something called completing the square, and it'll make it so it can be factored. To complete the square with the quadratic, that's just your basic general quadratic form, follow these steps. Get all of the terms with an x on one side of the equal sign, and all of the terms with no x. So you want all your x's on one side, all your non-x's on the other. So you're just moving your c over. That's all you're doing. Divide the b term by 2, then square it. And add that number to both sides of the equation. Right now, we're just going to discuss this. You're going to have a nice set of step-by-step notes, and then I'm going to actually do the question, so it makes a little bit more sense. So you're taking the b value right now, whatever it was, you're dividing it by 2. So if it was, say, 100, you divided it, no, I'm going to do that in another word. Say it was 10, we divided by 2 to 5, we squared it to be 25. And we're adding that number to both sides of the equation. Now, factor the blank, blank, blank on the left side of the equation and add blank, blank on the right. I don't remember what all those blanks are. You just factor the equation on the left. Factor the quadratic equation on the left side of the equation and add on the right. I don't know what those are. All you do is factor it.
Yeah.
Yeah, by a value. Oh yeah, greatest common factor. There we go.
Yes.
Yeah, factor it. That's what the 3 blanks are. Greatest common factor is what it's called. Yeah. Thank you. I was like, how do we have factor in 3 words? You just factor it. Yeah, you take the greatest common factor out of the left of the equation, and then you put it to add it on the right side. So if it was like you factor out a 2, you're just going to divide that 2 to the other side.
And it adds something.
It's like bank on the right side. You've already added it. That's a typo. You add that, it's b divided by 2 squared. But we've already done that stuff. I put it in words instead of having blanks. Because that's kind of a weird thing to blank out. Soccer.
What is that? What is that?
This last sentence,
Yeah.
don't sweat it. We've already rewritten it up here in better words. You've added that b divided by 2 squared to both sides. That's all you've done. And then on the bottom is square root both sides of the equation. Square root. And this is all words, so it might not make sense. No. Yeah, negative to the power 2. The best way to do this is words for if you're someone who likes to see the math written out step by step in words. We're going to do questions. I think that's the best way to learn. So let's look at this. Factoring. Okay, what multiplies to be negative 16 and adds to be 6? Eight and negative 2?
Yeah.
So that would work out perfectly. So you would just change it to be x plus 8, x minus 2 equals 0. And your answer is x equals negative 8 or 2. That's the type of question that should be on your quiz tomorrow. Nice and easy. You tried the diamond method. Where have you been? You need to put your phone away a little
No,
more.
I haven't even been on it.
I've talked about the quiz 3 times. We had like a 5-minute class discussion on it. Yeah, we have a quiz tomorrow to start the class. 20 minutes long. Football players, you're ready to do your BLT.
I totally remember this.
Yeah, oh, there we go. Like we literally stopped the class. This beautiful question. Nice and easy. P. Diamond method it. What multiplies to be negative 4 adds to be 5?
A whole lot of nuts is no.
Negative 4, negative 1.
I don't know. Like, parts? No, because the negative 4 has to be negative.
Right. So,
Oh, okay, so I was right. Yeah.
negative 4 and negative 1, if you multiplied them together, wouldn't work. That would be a positive 4. Okay, what's another thing that would work? Nothing would work. So when you get an unfactorable question, If you get an unfactorable question, you're going to complete the square. So you're going to follow our weird steps. The first thing you're going to do is you're going to move everything that's not an x to the other side. This right here, no x. Move it to the other side so it's a plus 4. And now you have x squared plus 5x equals 4. Awesome. That's the first step. The second step is the weird one. The second step is take your b value. I would suggest paying attention. You're going to take your b value, which is 5, and you're going to divide it by 2, and you're going to square it. So 5 divided by 2, square it. I chose 5 because that's my b value. Whatever your b value is what you pick. 5 divided by 2 is 2.5. Once you get into decimals, you don't want to do that. So just leave it like that. Leave it as 5 divided by 2 squared. Leave it in that format. Now you want to take what we just found and you want to add it to both sides. So if we add something to both sides, we haven't changed the equation. We balanced both sides. So that's what we're going to do.
So is that 5x no longer be there then?
Note, the 5x is still there. This is a completely separate term that we've come up with that we're going to add to both sides. Ty, how can you do that? That's a great question. You're just going to have to trust the process and see how it works out.
I don't like this.
No, we have just chosen the b value. It has nothing to do with this x right now. We're not moving this x anywhere. The x is where it is. It's just staying there. Okay?
That's what I was saying.
Someone's smart.
Who's like, yeah, this works every single time.
Add the b divided by 2 squared to both sides. So now you have x squared plus 5x plus 5 over 2 squared. And you're adding it to both sides. 4 plus 5 over 2 squared. And now you have something on the left that actually is factored. I know it looks kind of crazy, but it really is, trust me. So the equation on the left, if you were to diamond method it, you're going to have a hard time, right? You're going to be like, what's going to multiply, two things multiply to be this and add to be 5? Not quite. I'm going to show you what works really nicely. If we have two things that need to multiply to be 5 over 2 squared, but they also have to add together to be 5. What two things add together to be 5? 2.5 and 2.5 would add to be 5. But 2.5 times 2.5, that's just 5 over 2 squared. This is 5 over 2 times 5 over 2. These two numbers multiplied together would give you 5 over 2 squared. These two numbers added together give you 5. That's why we had to choose b over 2 squared. There's a reason why we picked what we picked. Because now it actually works out that we could diamond method it. So what you end up with, if you were to do this in your diamond, which is what you guys are so used to, you have, what would multiply to be 5 over 2 squared? and add to be 5 over 2? Well, the answer is just 5 on the bottom. The answer is 5 over 2 times 5 over 2. So how would that look for factors? You would have x plus 5 over 2 squared. So I put this on the left side. I factored it. It will work out to be exactly what that weird number is that we put in there. It'll work out every time to be that weird number that we put in there. And sometimes it won't always be a weird number. Sometimes it'll be a nice number. A lot of the time it'll be weird. No, not quite. Okay. Now, got
So if you divide a number by 2, then square it, it'll equal the number that I chose.
yeah, so we're making, by adding that to both sides, we're making that our A value, or our new C value. I know this is complicated, I know this is hard, that's why we're going to break it up over 2 days. At this point, you want to isolate for x. Solve what x is. Square root both sides. So you're going to have, I'm just going to extend the page. Oh, I'm not going to extend the page. Yeah, I'll extend the page. Okay. I know it's a little burning on the ears. I don't know, all written down by now. We're square rooting both sides because we have x plus something squared, so we have to square root both sides. On the left, all you have left, I'm going to switch to blue so we don't mix up our work. X plus 5 over 2 is equal to the square root of 4 plus 5 over 2 squared. I just square rooted everything, that's all I did. The squares and the square root don't cancel out. Remember, it's a binomial. This is like the question we went over on the test. It's a binomial. That square root applies to both the 4 plus the 5 over 2 squared. And the final step, not actually, we forgot to do plus or minus. The final step is to move the 5 over 2 away from the x. So subtract 5 over 2 from both sides.
Why is this very strong like the 5 over 2 squared?
The 5 over 2 squared? Because it's a binomial, right? So binomials, when you square root them, they're stuck together. You have to square root the whole binomial. So that means it can't just cancel out. If it was multiplication, it would cancel out. We're going to subtract 5 over 2 from both sides. Again, it's because it's a binomial. Yeah. The only way you could reduce it is if you put that square in, so it'd be 25 over 4, and then add those into one fraction. But I don't think that's going to help us, it'll just make it worse. Subtract 5 over 2 from both sides. So your final answer is x is equal to negative 5 over 2 plus or minus the square root of 4 plus 5 over 2 squared. That would be your final answer. Todd.
Okay, so 5 over 2 is 5 over 2 times 5 over 2, right? Like,
5 over 2 squared is 5 over 2 times 5 over 2.
why don't we do that? Why don't we simplify that?
That's a big news.
So just,
This one in here, you could put 25 over 4 if you wanted.
yeah.
Yeah, you could. Yeah, that'd be fine. It would just be another way of writing it. That'd be fine, yeah. Let me a question, just stretching. Megan.
If I pick the square root over the plus
It just applies to the square root. So if you wrote this with that part on the back, which a lot of you probably did, that's okay. That'd be fine. Johnsy. You could. I don't know if you want to, but you sure as heck could. Jason,